Welcome everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to solve systems of equations algebraically using the substitution method. How are we learning it? Through the systems of equations using Substitution Part I notes and systems of equations using Substitution Part I assignment. When can we use this information? To find economic solutions to financial problems such as income versus expenses and supply versus demand. How do we know we learned it? By getting a score of 4 on the systems of equations using Substitution Part I assignment. Now let's take a look at our agenda for today. We will begin by going over our learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed the Get It Started, we'll go over it together and answer any questions that you may have. After that, we'll go over the solving systems of linear equations using Substitution Part I notes. And then I'll give you time to complete the solving systems of linear equations using Substitution Part I assignment. Once you've completed the assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to continue working on the systems of linear equations and inequality study guide and any incomplete assignments that you may have. Let's take a look now at the solving systems of equations using Substitution Part I notes. Our notes begin with the learning goals and success criteria. Now let's take a look at how we can graph systems of linear equations. So all this really means is we're going to graph both of these lines at the same time. So on the first one, we'll go ahead and graph this. So we're going to plot our y-intercept, which is -2. So we're going to go down 2 and plot our point. And the slope is 1/3. So we're going to go up 1 to the right 3, plot our point, and connect the dots. So just like we did earlier, that's the same thing we're going to do now. Now, we're just going to plot the second line on the same graph. So my y-intercept for this one is 3. So I'm going to go up 3 and plot my point. And my slope is -1/2. So I'm going to go down 1 to the right 2. Connect the dots. And notice now I have a point where they intersect, which is right there. That is considered the solution to the system of equations. Now let's talk about how we can solve these systems using substitution. So we have two equations here. Y equals 2x minus 3. And x plus y is equal to 6. So the first thing we're going to do is isolate one of the variables, which means we're going to get one of the variables by itself on one side of the equal sign. Well, the nice thing is we already have that right here. We have y isolated. So we know that y is the same thing as 2x minus 3. So what I'm going to do is I'm going to plug in the value on the other side for y into the other equation. So I have x plus y is equal to 6, but y is really equal to 2x minus 3. So I'm going to plug that in. So now it says x plus 2y minus 3 is equal to 6. Now I can solve for x. So I combine like terms. I get x plus 2x is 3x. So I have 3x minus 3 is equal to 6. Then I'm going to add 3 to both sides. And I get 3x is equal to 6 plus 3 is 9. Now I can divide both sides by 3 to get x by itself, and I get x equals 9 divided by 3 is 3. So there's my x. So that's the x coordinate of where they cross. Now I need to find the y coordinate. So I'm going to plug it into one of the equations. It doesn't matter which one. I'll use this one, x plus y equals 6. But x is really 3, so I'm going to plug in 3 for x and then solve for y. So I'm going to subtract 3 from both sides, and I get y is equal to 6 minus 3 is 3. So when x is 3, y is 3, and that's the solution for both of the equations. Now what happens if the variable is not already isolated? So that's our goal, is to get one of the variables isolated. Now if they're not isolated, we can go ahead and take one of the equations and move everything away from one of the variables, and that will isolate it. So in this case, I'm going to take the equation y minus 2x is equal to -3, and I'm going to isolate y. So in order to do that, I'm going to add 2x to both sides, and I end up with y equals 2x minus 3. Now it's isolated. Now I can go ahead and plug it into the other equation. So I have x plus y equals 6, but y is really equal to 2x minus 3, so I'm going to plug that in for y. So now it says x plus 2x minus 3 is equal to 6. Now I can go ahead and solve. So I'm going to combine like terms. So x plus 2x is 3x. So I get 3x minus 3 is equal to 6. I'm going to add 3 to both sides to get rid of this. So I get 3x is equal to 6 plus 3 is 9. Now I'm going to divide both sides by 3 to get rid of this 3. And I get 9 divided by 3 is 3. So x equals 3. Then I plug it into the other equation and solve. So I'm going to pick either equation, doesn't matter which one. I'll pick this one. And I'm going to plug 3 in for x. So I get 3 plus y is equal to 6. Subtract 3 from both sides to get y by itself. And I get 6 minus 3 is 3. So x is 3 and y is 3. Now there's a video here that shows you how to check systems of linear equations in Desmos. So go ahead and watch that video. Let's talk now about how we can use Desmos to check our work when dealing with systems of linear equations. So first thing we're going to do is go to desmos.com, which is here, and we're going to click on Graphing Calculator. Now, this allows us to type in our equations over here. So let's go ahead and put in an equation. So let's say it's y equals 2x minus 4. So there's our first equation. Now we're going to type in our second equation. So we're going to go to the line below it. And let's say it's y equals negative 2x plus 4. So there's my two lines. And if I go to where the two lines intersect and click on it, I can see that it gives me the coordinates of exactly where the two lines intersect. They intersect at x equals 2 and y equals 0. So this would be the solution to my system of equations. And I can do this by inputting any two equations and then going to the point of intersection and clicking on it. It will tell me what the coordinate of that is, with the x coordinate first and the y coordinate second. So this is how you can check your work using Desmos when dealing with systems of linear equations. Let's take a look now at the solving systems of linear equations using Substitution Part I assignment. Our assignment begins with the learning goals and success criteria. If we scroll down, we can see the questions. The first one says y equals 6x minus 11 and negative 2x minus 3y is equal to negative 7. So what we're going to do is we're going to plug this part in for y in the second equation. So it should say negative 2x minus 3 times 6x minus 11 is equal to negative 7. And we'll solve that. And when we do that, we should recognize that x is 2 and y is 1. So it's this one here. So we'll answer each of these questions just like that. So we'll use substitution, plug in what we know, isolate a variable, and then plug in what we know. So we'll plug in what we know, which is here, after isolating the variable, and we'll plug it in for that value. So we'll go ahead and isolate a variable, which is already done in this case here, and then take this value here and plug it in for that variable, and then solve. That should give us one of our variables, and then we'll plug that value into one of the equations and solve and get the other value. So you'll go ahead and do that for each of the questions, and then when you're done, you'll click Next. This will take you to your Before You Go. Go ahead and fill out your Before You Go, and then submit your work on Google Classroom.